Hey YouTube, it's JP Dillon. Today we're looking at a Marantz 2240B with a more common emerging problem that is happening in the FM radio, having to do with the FM multiplex. And the complaint will be the FM does not receive stereo. The light doesn't come on, there's no separation. And so most techs will think to look at the multiplex chip, which is usually the HA1196, which is readily available, and they'll replace the chip and they'll go, that didn't fix it. Well, the problem at hand really isn't the multiplex itself so much as it is the muting circuit. Yes, the muting circuit. And the reason why is on these Marantzes, the muting circuit is responsible for two things. If it falls below the threshold which would trigger the muting, not only does the audio mute, but the multiplex shuts off. And I'll show you that in a little bit. This is using the P300 multiplex board, which is found in a number of Marantzes, and pretty much every single one I've seen with that board has this problem at some point in its lifetime, so we're going to address that. This has been to a couple of other shops and they haven't figured it out yet. So let's power on here. I've got it hooked up to my signal generator, and as you can see, no stereo lights on right now. And if I go over to the scope here, and if I switch over on my sound tech to just the right channel, we see that there's no stereo separation at all. And if I crank the RF level way up, that doesn't change. Still got no separation. So turn the RF down, still no separation, no muting or nothing because the muting is switched off. So let's crank the signal all the way up. Let's say about 20,000 microvolts. Now, if I turn the muting on, watch what happens. It acts like there's no signal, even though we're registering a pretty hot signal here on the signal strength meter. Turn muting off, and we're good. So the failure is actually in the muting circuit. So let's take a look at the schematic. I'll show you what I mean. Okay, so here's the schematic diagram. This is your multiplex circuit here. And so the signal comes in from the detector and hits the drain of H301. This acts as an input impedance buffer, very high input impedance, and then feeds through here to the input of H321, which is an 1197, excuse me, 1156 IC. Okay, so you have your 19 kilohertz amplifier here, and you have your 38 kilohertz switch. So this is actually responsible for turning the multiplex on and off, because what it does is when it is on, it pulls pin 9 low here, which switches the 38K on and off. So down here is your muting circuit. And what this is just a differential amplifier, and then this is your trigger. And so what happens here, can't really see it because I'm off screen here. Let me move this over a little bit. So it comes in on J308, which basically comes from the third IF filter, and it's just monitoring signal amplitude. And so if the signal coming from the IF is hot enough, it turns this on, and basically this switch here turns on a voltage source, which is here at R351, which is nominally about, there should be about 10 volts here according to the schematic, and the 10 volts turns on this transistor here, H317, which then pulls down this line here, which controls the H303, which then turns on and turns the multiplex on, and it also is supposed to unmute. Now, if there's not enough signal here, then basically this transistor array here turns on, and that turns this guy off. H317 becomes off, and what that does is that turns off the stereo multiplex chip And it also changes the voltage potential here at the downside of R352, which goes up to the gate on H301 up here. I keep moving the camera down, sorry about that. It turns off the gate on H301, and the signal to the multiplex just completely goes away. And I think it also controls the audio output transistors over here, because the sound completely and totally goes away. So what we have to do is we have to look at the common point that would cause the problem. Now, right now, we're focusing on this area here. And the reason why here is that no matter what conditions are met, at the bottom side of R351, which is the 100 ohm resistor, we have almost no voltage at all. Now the supply line, which is the 12 volt supply line, comes through R353, which is this guy up here, to that junction point, and then goes through R352, which is the 33K, and then the 33K goes through R351, which is the 100 ohm, the low side of which is C332, a 10 microfarad capacitor, and ground. Now, what I do know is that we have voltage at the high side of 352. We have 11 volts at the high side of 352 and the point at 353. So right here, we have 11 volts. So that would eliminate C328 as a probability of leakage or shorted. So that capacitor is fine. However, on the low side of R351, we have almost no voltage. On the high side of R351, we have about 6 volts. So that explains why, when I turn the muting off, we have operation, because of the voltage at the low side of 352 were low. It would pull down H301, and we would have no operation of the FET. The gate would be off, and there would be no flow through H301. We have no sound. So, one thing I have found is if I substitute the voltage at the bottom of 351 with a sub power supply, the circuit will unmute and the stereo will come on. However, when the signal threshold gets too low, it will start to motorboat and oscillate and do all sorts of weird things. So I'm guessing that H308 and 309 are trying to turn the circuit off but can't. So my suspect here is C332, which is the 10 microfarad capacitor, 16 volts. If that's leaky, given the low amount of current that's allowed to flow on the low side of the 33K and then on the bottom side of the 100 ohm resistor, it could be that C332 is in fact leaky. Now, it's not shorted. I know it's not shorted because if I hang an ohm meter there at the top of C332, I get a fairly high resistance. But you still have to wonder if this is supposed to charge, the C332 is supposed to charge to hold a voltage there to help buffer the voltage for H317. So let's do some checking and with the machine on and see what we see here. So right now, someone has replaced H309 from the top side nonetheless. So if we look back at H309, I should have the appropriate voltages there. I know the collector is wrong. The emitter is 100 ohms off ground, so we should see, they say 0.05 volts there in mute mode. Or actually, no, it's 0.63 in mute mode, 0.05 in non-mute mode. So looking at the base, we have 0.04. So in theory, that should be in non-mute mode. We have diddly on the emitter because that's pretty much at ground, 100 ohms off ground. But our collector supply, we have almost nothing. Now, normally if there was a dead short, I could turn the machine off. But it doesn't drop to zero, it just slowly drops. You can see it slowly bleed down. And eventually it gets there. So it's not a hard short. It's Definitely not a hard short. Now let's see. Where's that capacitor? The 10 microfarad capacitor. Was this it? It's hard to tell here. Let's take a look again. Yeah, so that's C332. That's this guy right here. Yeah, let's look at the high side. Let's set this to ohms. And looking at the high side of 332, it charges up. And we get a fairly high resistance there. 32K. Interesting, because 33K is the supply resistor. And if we go to the low side of this, then there's our ground, or close to ground anyways. So let's test our theory and see if the capacitor is bad and it's just simply not holding a charge. And coming in here with the capacitor wizard, that capacitor has good ESR. So that would make one believe that the capacitor is not at fault. So if H309's been replaced and our C332 looks good, what else could be pulling that voltage down? So what we do is we follow this line. And let me get the cursor here. We follow this line and we find out that there are a whole number of transistors that share that line. So we have H311, we have an FET, H312, but that's blocked by a capacitor. Let's see what else here. So it looks like 311 and 315 are also probable candidates if either of those transistors have failed. Although R371 is through a 220 ohm resistor, so there should be some less influence there. However, H311, that could be a problem. If H311 has leakage or shorted between collector and emitter, that would definitely pull the voltage down. Or if we have, let's see, a 310 is active, 310, oh no, you've got H319 as a blocking diode there, so that really doesn't work out too well. Of course, if this were on, that would then turn H311 on, which would then pull this voltage down. So let's check the voltages. Let's move this over here, 310 and 311. And let's see where 310 gets its bias from. And that's going to be, make everyone dizzy point, so that comes in on 317. Let's see where 317 goes. That's just an extra detector output. 317 goes to the quadradial output, which is your Marantz's fancy way of saying 4-channel. So I don't know if that's a 25 microsecond discrimination change for the 4-channel multiplex. Don't really know. Yeah, but that's just another input. Okay, so let's see here what else this influences. And then we've got 316, which is not part of that line, but is part of H303, which is the switch. So we've got some sleuthing to do here. We've got H310, 311, 315, and 316. So let's do some poking around here. So 310 is down here. And if all is cool, we should have about 12 volts on the collector. We got 11 there. We should have about 2.5 on the base. We have 2.28. And then on the emitter, I read 1.64. See what they wanted there. And they wanted 1.9, so we're 2.8 and 1.9, instead of, or 2.8 and 1.6 instead of 2.5 and 1.9. So we're pretty close there. So I think we can rule out H310 as the culprit. Now H311 is down here, and we should have 0.03, and we have 0.009, so that's low. 0.00000, that's the emitter at ground. We have 0.1 here, so the voltages on 311 aren't right. Now that could be because of that supply voltage that was being pulled down. Let me just check this for a short real quick. I don't think we have a collector emitter short. That's 1.2 meg, and the emitter is always at ground on this one, which it still is. So no shorts to ground. Let me just check and see if there's a base collector short. And there isn't, so that's one to keep an eye on. So H311 was wrong. And I suspect that H315 is probably going to be wrong too, because it also shares that same line as does H314, although we can check and see what's going on with that there. And it just so happens that 314 is right there. So nothing on the emitter because that's at ground. 0.02 on the base. And nothing on the collector. And what's even more interesting is that when I influence the collector, things start getting twitchy. See how it's jumping and stuff? That's a point of sensitivity. Should make note of that. So, yeah, voltages on that are kind of wrong. It doesn't surprise me, really. And then 315 is just adjacent. And 315 is hard on. I've got 0.6 of a volt on the base. Diddly squat on the emitter, because that's at ground, I believe. Let's move this out the way. And 0.05, which is, oh wow, it's just like jumping around. Come on, jump around for me some more, now that you're on camera, of course. It was basically bobbling around all sorts. And if I go back to the base here, that's hard on. 0.62 on the base. And you can see that's supposed to be 0.46 on the base there. And that voltage is set by R363, which is a 10K, but level potentiometer. So we might see if we can dial that in a little bit better. But definitely 316 was a point of sensitivity for sure. So I don't know if that transistor's bad, but there's definitely something of interest there. And then you've got R374, which affects H316 too. Okay, so here we have a point of interest, H316. And on the schematic diagram, according to this, H316 is supposed to have the emitter be 0 volts. And if I come here, that is certainly not 0 volts. It's more than 0.6 of a volt. I should have 13 volts on the collector. I have 11.2. And then I should have 0.16 on the base. 0.16, all right? We got 1.2. So something is very wrong in this circuit. We need to figure out what's going on there. Now, let me see if I can substitute a voltage really quick to bring this down to see if it's the circuit that's causing it or just this transistor and adjacent circuit by itself. So I'm going to apply a bias to this point here, which I put in. And let's see if that changes things here. Nope. Still 1.2 volts there. 0.6 of a volt there. So there's something very wrong with H316 and its associated circuit. I just used that bias test point there to test my theory about the muting circuit. Because as I had mentioned before, if you substitute that collector voltage at H309? If I substitute 10 volts at H309 like it's supposed to be there, the circuit works until the threshold gets low. Now, when we see a full 1.2 volts on the base of H316 and half a volt or 0.6 of a volt on the emitter, it's dropping 0.6 of a volt across, but the reference isn't right there. So R374 should be 10K. And that voltage from J316, if we follow that, see where this goes. Curious now. That's part of our FM selector switch. And that can go to pin 9. If we follow pin 9 back, this is dizzying, isn't it? Now that just goes to our signal strength meter. Alright, so that could be a signal strength meter driver. I wonder if that voltage on the base will vary when I adjust the RF signal. Alright, so I'm going to poke on the base here, looking at our 1.2 volts there again. And I'm going to see if adjusting the RF amplitude downward changes that. Oh yeah, it sure does. Alright, so that's a false alarm there. Yeah, that's just the meter driver. That's just doing its job. Alright, so we can ignore H316 as a culprit for this failure, because that base voltage just varies based on the RF amplitude, which makes sense since it's the meter driver transistor. Okay, so I think we're making a breakthrough here. If we go back to H309, you see I've got my WB519A, and I look at the resistance between the collector and ground. It's pretty low. And see how it changes? Now, as it changes, if it'll happen here as I test this, the resistance goes up as the circuit kicks on. You can see that. It goes from mono to stereo. And when that happens, the resistance goes way up. So there's mono. Come on, do it for me. No, you're not going to do it now? Well, anyways, you were seeing it. The resistance goes way up as the circuit goes into stereo. So right now it's about R times 10, 10K. So it's about a 250K thing right now, but it was shooting up to about maybe, come on, it's thinking about it. Twitch, 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 there we go. Yeah, so significantly goes up about a meg. So definitely something on that line is wrong. Now, we had originally kind of poo-pooed C332 there, but I think I'm going to yank it out and see if substituting it gets us our voltage back. Now, I've completely removed it from the circuit, and we still have our failure. And we can see that the resistance is rising ever so slowly. Oh, and there we go. Now it's on, now it's off. Now it's on, now it's off. So there's still something in that line that's wrong. but it wasn't the cap. So my original suspicions of it not being the capacitor were correct, because I totally removed it from the board, and we're still suffering points of failure. So something else in that line is pulling it down. It's not the capacitor. And re-exploring this line, it's, H309, which we have replaced. C332 is out of the picture, so that's not it. So we got something else in this circuit that's influencing this. Now, what are the chances that H317 has a base emitter leakage? Pretty small. I can disconnect H317 and we could see if that affects the problem at all. But I'm more suspicious of things directly fed from that line, particularly H311, 314, and 315. Now, as we were poking around here, I believe 314 and 315 were of the greatest influential change. So let's go back to those two real quick. All right, so here's H314. And I was getting some strange readings on this in 315 before. We're looking at it with VOM now. And let's see here. Getting some erratic activity. Let's go back to the DMM. It's a little more sensitive. So 314. That's on the base. It's on the emitter, which is supposed to be at ground. So base and collector aren't too far off. And then 315. See, 315. Yeah, 315 was hard on. Let's see, not much on the collector. More on the base than the collector. Emitter's at ground. So that's interesting. 0.03 on the collector, 0.6 on the base. Makes me wonder if this transistor is even doing anything. And I think the collector does share that line. 14 and 15 both, and 11 all share that line. So it makes me wonder if I'm just going to have to clip the leads of each one until that voltage comes back up, and then explore that circuit a little more. Okay, so I cut the supply line to H315, which was the one that had the most sporadic readings and problems here. And on the high side of that line, I've got 9 volts here. So now that that transistor is out of circuit, I got 9 volts. I wonder if I got 9 volts back here on the collector. Yep. All right, and I got stereo. And if I turn the muting on, it doesn't mute until we go below a certain threshold. And we get our motorboating thing again. So something still isn't right in that circuit. But H315 was the culprit pulling that down. And we still got this little twitch thing going on, which may be a part of that since the base emitter junction is still on circuit. But interesting, huh? So what does 315 actually do? Okay, so I've got my VOM between the collector and emitter, which is now out of circuit. And you can see that there's quite a bit of leakage there. If I take that away, there's no leakage. If I touch the two again, quite a bit of leakage there. So that transistor is defective. And that's really the ultimate cause of this problem. And these are all 2SC828s, which are showing up more and more as leaky. Now, typically, it's true that the 10 microfarad capacitor is usually the cause of this. But today, it's actually a transistor which was in the line that fed a H309, which was responsible for your switching and muting. So let's replace that transistor and install our 10 microfarad capacitor again and see if everything's cool, because nominally with that transistor out of circuit, it kind of sort of functions, although it still has the motor boating and other issues, which I think will go away with a replacement transistor. So let's get that in there. Okie dokie. So we got our fresh transistor in there. I'm just using a 2SC 1845 with a beta of about 350. Our 10 microfarad capacitor's back in there. I see a stereo light. And there's our stereo separation, left from right. And muting is on. And if I kill the RF signal, it absolutely mutes. No motor boating or nothing. That's lovely. And let's see if we can touch up the 38 kilohertz demodulator here. Tweaky, tweaky. See if we can improve the sensitivity, the separation ever so slightly. Yeah, much better. All right. Okie dokie, folks. That's going to wrap this one up. So, yes, it could be C332, but it wasn't. It wasn't C or H309. It was, in fact, H315, which shared the same line, which I guess acts as a quick clamper, because without it, it would motorboat and stuff when it would go into mute. But perhaps we're not fixed. What was that twitch? Twitch, twitch, twitch. Something twitching. Come on, do it again. Yes, no, we're going to malfunction. It was doing that weird twitch thing. See that? What's causing that? And we had, what was it, 314 too. Let's check H314. Maybe we got some twitching going on there. That's, since it is the same transistor. H314. Looking good on the base. Emitters at ground. Da-da-da. We got our collector voltage back there. That's pretty rock stable. Let's get out the oscilloscope. Looking at my mess there. And let's probe around here. So let's see, 308. Let me crank up the sensitivity here. So 308 on the base. It's rock solid there. See that? That's on the, shit, where is that? That was on the emitter of 308. See it freaking out there? Maybe that's just me being in the wrong. Maybe my probe just wasn't seated properly, because it does freak out. Come on, do it again. Yeah, we're not done. Not done at all. Come on, are you going to act up again? I know you want to. I mean, granted, we still have a stereo and proper mute function, but where are those transients coming from? Okay, so I'm properly seated on that emitter. Yeah, of course, it's going to be quiet now. Absolutely quiet. This is the base of H317, which is our switch. Looks pretty solid there. Yeah, you can see it's still twitching on the audio on the right side there on the bottom. Still twitch, twitch, twitch. And that's good there. Let's go back to 314 again. .314 is pretty solid. Let's go to the base of 315. There's our twitch. All right, so what's feeding 315? Yeah, base of 315's all over. That's that fresh transistor we just replaced. So something feeding that line. Let's take a look and see where that goes. So 315 is fed ultimately from 312, which is that FET is probably a 2SK30. That's what they like to use. Yeah, so it's probably, we'll check the drain and the source on that guy. Let's check the source of 312, make sure it's not going twitchy. That's the only thing feeding that. I mean, we can check H313 too and see if it's got that wonky signal there. And if it does, then that tends to nail the FET. And if it doesn't, then we have to look at H314 again. Of course, that wouldn't, the collector signal was cool. It's just the base was all over the place. So, yeah, I got to look at that. 313 and 312. Okay, so looking at the base of 313. Of course, now it's not going to do it. Come on. Camera shy, let's go. Come on, twitch. I guess I'm going to babysit it and see when it occurs. Alright, now we're starting to get a little twitch there. Yeah, 313 is not influenced as highly as like 314 and 313. Very little influence. 315 that I just replaced. Look at that, Twitch-O-Matic. Let's see what's on the emitter side. Yeah, emitter's quiet. But the base at 315 is just all over. Look at that. It freaks it out, man. Alright, so where's 312? That's your FET. 311, 316, 15, 14. Come on, where's 312? There we go, 312. Let's look at our drain here on 312. Wow. So I would say that we have an issue going on with that FET. What would you think? Yeah, that's the drain on 312. Let's look at the source. That's not much better, is it? Whew. Now let's look at the gate. Yeah, I know, everything's going to be crappy for a moment. And we've gone into failure mode now. Now it's back into its mutatastic state. That FET voltage is just everywhere. And there's the drain. The drain looks the worst. There's the source. Bobble bobble. And then, yep, that's not good. And let's take our voltage measurement again. I know, I'm just all over the place here. You're going to just have to bear with me. That's off. Hard off. And now that's pulling that down again. Yep, just on that low side. Alright, so some sort of influential thing here is happening. So we got 11 on the drain. That gate voltage is all over too. Look at that. And is that a cause of the FET itself? or something else. And then we come over to here to the source. Source is going nuts. So it's hard to tell if it's the FET that's actually wrong or something influencing it. So according to that, we're supposed to have 12 on the drain and 10 on the source. So if we come over here, we got 9 on the drain, 6 on the source, and that's all over. But why do I have voltage on the gate? Gate should be nothing. And see how it's going all over? 6, 3, 6, 5, and 7. So I wonder if this FET is defective. I'm trying to think of what could be feeding it that gate voltage. I mean, it looks like that the gate voltage is ultimately controlled by R362, which follows down to J309. Where does that go? J208. And that's a takeoff from H208, which is in the IF stage. And there could be a capacitor there, C244, that could be leaky. Or intermittently shorting too, that could be fun. So, yeah. So we'd have to come to J208 or see what the voltage is on the low side of that pot. Because if it's, well, actually on the high side of the pot. So if the voltage is higher than the gate on the high side of the pot, then we have a leaky capacitor in the IF stage we need to change out. But if it's lower on the high side of the pot, then the FET's to blame. So let's see, where did they say that went? J308 or 309? So let's look at the voltage at J309 versus the gate. So at J309, we have 4.2 volts. At the gate here, we have 6.7 volts. And it's all over. So since the voltage is higher at the gate of the FET, going through that pot, the FET is defective. What are they using here? Yeah, H312, 2SK30. That's pretty much the lovely go-to FET that everyone used for that sort of purpose. So we need to change that out and then see if that cures our issues. Well, I replaced the FET, which takes away our quivering and nasty transients and stuff. But we're also back to not having proper muting and switching function. And the source voltage on this guy is really low. It's supposed to be about 10 volts, and it's only about 1 volt. And I thought, well, maybe the initial FET was bad. But it's not. I tried swapping it with a couple, and that didn't really change anything. And the voltages, apart from the source, are correct. Because I've got 12 volts on the drain. I've got 0 on the gate. But the source is crummy. And so because of that, 314 through 315 aren't working properly. And so I need to figure out what's pulling down the source there. And nominally, I have a fairly high resistance to ground, except when I hook up my VOM. And then it looks kind of crappy. And it looks like it's a low resistance, so I suspect perhaps that capacitor, that 4.7 microfarad capacitor, is to blame for that. So we need to take that out of the circuit just to be sure. And then also, through that potentiometer in R365, we feed that stuff there, but since there's no voltage there, that's not really going to affect anything. So let's try the cap first. Yeah, removing the cap did nothing to change that. Now I'm wondering if 0 volts is in a mute condition and we're actually in a mute condition because of something else. That kind of makes me wonder a little bit. And let's see, the drain of that would be 303, which is the switch. So I wonder what happens if I add a bias to H312. I don't think it's going to matter too much. I'm going to give it a shot anyways. Okay, so if I add about a 5 volt positive bias to that, you can watch it switch on. And if we come over here to the gate, it's about 4.6. So we have to trace that line back and figure out why we're not getting that there. I think 0 is under a muting condition, because now this thing is conducting. And if we give it a little more, that's about correct. It likes having that there. And 2SK30 is an N channel, and I'm using a 2SK34, which is also an N channel. About the same amount of turn on. So let's trace that back and see if we can figure out why that stabilization voltage isn't there. Or maybe something's pulling down the source again. This is really a puzzler. Yeah, so following that line up, it comes in on J208, and I can't find anything here that would directly drive that. Because we do have this winding off the detector here, this guy here. But that wouldn't, I don't think that drives it directly, does it? Yeah, so that comes in over here. And it may just be signal amplitude that drives that, but that says 0 volts DC. Well, if I add a bias of about 5 volts to it, then this circuit works. So I'm a little bit stumped on this one. I called the owner of this thing, and he's not really willing to spend a whole lot of more time and money on it. And he's okay with the muting being defeated. He really just wants the stereo separation. So, because I can't really spend any more time on it since I wouldn't be paid to do so, I think what we're going to do is remove we can remove 315 from the circuit, and that should take care of our muting thing and give us our stereo back. It's too bad. I'm kind of curious about this stuff, but short of spending hours and hours on it, I won't be paid for. We're getting a little bit closer, and we're discovering more problems with it, but ultimately we haven't come to a conclusion yet. So this one's a bit of a puzzler. The old FET was definitely defective, but the new one, without a gate voltage on it, doesn't do much. So I don't know if I have to have a 2SK30, because the gate turn-on voltage threshold for a 34 and a 30 are pretty close. I wouldn't think that it would be that big of a deal. But ultimately, that threshold signal is fed from this little winding on the detector down through this to R273, J208, etc. And that then goes through R362, the 100K, which is a threshold adjustment, which turns on H312, and it just isn't doing that. So I don't know if it's because I have the wrong part or because there's still something else wrong. I mean, granted, I could bullshit it, and I could just, forcibly have the gate on all the time, but, why? When I can just remove one of the transistors from the circuit, and the muting circuit goes away, and it has beautiful stereo. So I think that's what we're going to end up doing, because he's not willing to spend the time and money to get this thing right. It's too bad, but, people have limits. Alright, so I ended up yanking the FET, and I just placed a 220 ohm resistor between the pins of the drain and the source, which provides the current necessary to just turn the transistors on and off. And now, I may not have muting, but I do have stereo separation. So Like I said, he doesn't want to spend any more money on this one, so we're just going to make it so that most of the functionality is restored. And I'll finish putting that all back together and pretty it up and put the case on. But anyways, hope you guys at least enjoy the journey. We didn't actually fix this one completely, but made it at least usable. Anyways, thanks for watching. More stuff to come.